Tonight, let's wonder about something that sounds like a story and turns out to be partly true. Could time travel ever be real? Settle in first. Let your shoulders drop away from your ears. Let the weight of the day loosen its grip, finger by finger, and let your breathing slow to the pace of someone with nowhere left to be. You don't have to follow every word. You don't have to remember any of this in the morning. If you drift off somewhere in the middle, that isn't a failure. That's the whole idea. I'll keep talking softly, and the universe will keep being strange, and you can come and go as gently as you like. Here's the first quiet surprise, the one that makes this question worth asking at all. Time travel is not entirely the stuff of stories. Traveling into the future is real. It has been measured carefully with clocks and satellites and particles, and it happens in tiny amounts to astronauts, to engineers, and to you every time you move. The future is a place you are always falling toward, and it turns out you can fall toward it a little faster or a little slower depending on how you move and where you stand. That part is settled. That part is simply physics. It is the other direction, the past, that holds the real mystery. Whether anything could ever travel backward against the current to a morning that has already happened. That question opens onto some of the strangest and most beautiful ideas in all of science. Tunnels through space, slowly turning universes, particles that may run backward through time, paradoxes that fold back on themselves like a story quietly eating its own tail. We'll wander through them slowly tonight, one at a time, like rooms in a very large and very quiet house. Each one stands on its own. You won't need to hold anything in your mind to follow the next. You can rest in any room you like for as long as you like. So let the lights go low. Let the questions be enough without needing their answers. And let's begin where time travel is already undeniably real, with a single human being who came home from the sky just slightly younger than he was supposed to be. There is a man alive today who has traveled farther into the future than anyone else who has ever lived. His name is Sergei Krikalev, and he is a cosmonaut. Over the course of his career, he spent more than 800 days in orbit. More than 2 full years of his life circling the Earth at a speed that is almost impossible to picture. The space station he lived aboard moves at around 28,000 kilometers an hour. At that pace, you could cross from one coast of a continent to the other in the time it takes to make a cup of tea. He went all the way around the entire planet once every 90 minutes, watching 16 sunrises and 16 sunsets in a single day for months at a time. And here's the strange and wonderful thing. Because he was moving so fast, time passed for him just slightly more slowly than it did for the rest of us down here on the ground. Not in a way he could feel. Not in any way that showed on his face or in his bones. But the clocks knew. When you move very quickly through space, your passage through time slows down ever so gently compared to someone standing still. It is one of the deepest and most reliable truths we have ever found about the universe. That time is not a fixed, universal thing, ticking at the same rate for everyone, but something soft and stretchable, something that bends with motion. The faster you go, the more it bends. For Krikalev, all those days at all that speed quietly added up. By the time he finally came home for the last time, he had aged a small fraction of a second less than he would have if he had simply stayed on Earth and lived an ordinary life. Somewhere in the range of a few hundredths of a second, a tiny sliver of time, less than the space of a single blink, but real and measured and his. He returned to the surface of the planet just barely younger than the world expected him to be. He had, in the most literal and honest sense the words allow, traveled into his own future. He skipped forward, by a heartbeat's fraction, past the moment he was meant to occupy. It is easy to hear a number that small and let it slide past as a curiosity. But sit with it for a moment, here in the quiet. It means the future is not a fixed distance away from you. It is not a wall you are walking toward at a steady, unchangeable pace. It is something you can reach a little sooner or a little later, depending on how you move through the world. Speed is a kind of currency, and what it buys you is time. And it is not only astronauts. The same gentle slowing happens to the particles that physicists send racing around their great circular machines, deep underground. There are tiny, fragile bits of matter that, when left to sit still, fall apart almost the instant they are born. They exist for a flicker, and then they are gone. But when those same particles are whipped up to nearly the speed of light, they live far longer than they have any right to. Their inner clocks slow down so dramatically that they survive thousands of times longer than they would at rest. We watch it happen, again and again, every single day. The faster they go, the more time stretches out around them, like a long-held breath. If you could somehow move fast enough, close to the speed of light, far beyond anything we can yet build, the effect would grow from a sliver into something staggering. You could leave on a journey, travel for what felt to you like a single year, and return to find that decades had passed for everyone you left behind. You would step off your ship into a future you had simply leapt across, while your own body had barely aged at all. This is not a loophole, or a trick, or a fantasy. It is just how the universe is put together. We have measured it. It is true. The wonder of it is not really the speed. It is what the speed reveals. That time, the thing we trust most, the steady drumbeat we build our whole lives around, is not the same for any two of us. Yours is a little different from mine. A traveler's is a little different from someone who stays home. We each carry our own private clock through the world, and they do not all agree. And so somewhere above you tonight, far overhead, the people drifting through the dark in their small bright station are slipping into tomorrow, a fraction of an instant ahead of the rest of us. Quietly, without effort, sound asleep in their tethered sleeping bags, floating, while time itself runs just slightly slow around them, and the earth turns below, patient and blue, waiting for them to come home a little younger than they left. Imagine two sisters born on the same morning, only minutes apart, identical in every way. The same eyes, the same laugh, the same age down to the breath. Now imagine that one of them leaves. She boards a ship, the kind we cannot build yet, but the kind the laws of physics fully allow, and she flies away from the Earth at a speed close to the speed of light. She travels out toward a distant star, turns around and comes home. To her, the journey feels like a handful of years. She eats, she sleeps, she watches the stars drift slowly past her window. She arrives back at the same front door she left from, still young, still strong, only a little older than the day she departed. And her sister, the one who stayed, is now an old woman. Decades have passed on Earth while only years passed on the ship. The traveler steps out, barely changed and is met by a sibling with gray hair and a lifetime of memories she was not there to share. They were born the same minute. They are no longer the same age. They are not even close. This is real. This is what would actually happen. Not a story, not a metaphor. A direct and tested consequence of the way fast motion slows down time. The faster the ship moves, the more sharply its clock falls behind the clocks on Earth, and over a long enough voyage, that gap grows from a sliver into whole generations. But here's where it becomes a genuine puzzle, the kind that has tangled people up for 100 years, because there seems at first to be a problem hiding inside it. Motion, you see, is relative. There is no special, fixed point in the universe that everything else is measured against. When the ship pulls away from the Earth, the sister on board can just as truthfully say that she is sitting perfectly still, while the Earth and her sister upon it go rushing away from her in the opposite direction. From her window, it is the Earth that is moving. From the Earth, it is the ship. Both views are equally valid. Neither one is the real one. So if it is the speed that slows down time, and if each sister can rightly claim the other is the one who is moving, then why doesn't it work both ways? Why doesn't the traveling sister come home to find her earthbound sister younger? They should each see the other's clock running slow. They cannot both end up older than the other. Someone has to actually be younger when at last they stand face to face. So who? The answer is quietly beautiful, and it lives in a single word: turning. The sister on Earth never changes her motion. She stays in one steady, unbroken state from beginning to end. But the traveler cannot complete her journey without turning around. To come home, she has to slow and stop and fire her engines to push back the other way. In that turning, in that pressing of her body into her seat, that long moment of force and motion changing, the perfect symmetry between the two sisters breaks. Only one of them feels the journey in her bones. Only one of them is pushed and pulled and turned around in the dark. And it is that one, the one who truly travels, whose clock falls behind for good. It is not that the universe plays favorites. It is that their two paths through space and time are genuinely different shapes. The stay-at-home sister takes the straight, simple road. The traveler takes a long loop out and back, and strange as it sounds, the looping path is the shorter one through time. She lives through less of it. She arrives having spent fewer hours, fewer heartbeats, fewer days, even though she went so much farther. And this is the thing worth holding gently as you rest. We tend to imagine time as a great river that carries all of us along together, side by side, at the same unhurried pace, everyone in the world floating downstream into the same single future. But it isn't so. Each of us moves through time on our own private path. Stand still, and you take one road. Travel far and fast and turn around, and you take another. The two roads can begin at the very same moment and end at the very same moment, and yet contain wildly different amounts of life between them. Two sisters, born the same morning. One stayed, one went out to the stars and came back. And when at last they sat together again, in the quiet of some ordinary evening, holding hands across all those uncounted years, only one of them had grown old. The other had simply taken the long way around, and arrived, somehow still young, into a future that had quietly run on ahead without her. The clock on the floor beside your bed is running slightly slower than a clock up on a high shelf across the room. It sounds impossible. Surely a clock is a clock, and an hour is an hour, no matter where you happen to set it down. But it is true, and we have proven it, and the reason is gravity. Here's one of the gentlest and strangest facts we know about the universe. The stronger the pull of gravity where you are, the more slowly time passes for you. Down low, closer to the heavy heart of the Earth, gravity is just a touch stronger, and so time runs just a touch slower. Up high, farther from the planet's center, gravity loosens its grip a little, and time runs a little faster. The difference is unbelievably small across the height of a single room. But it is not zero, and it is not imaginary. Physicists have actually done this. They took two of the most precise clocks ever built, and they raised one of them about a foot, roughly the height of a single step, above the other, and they watched. The higher clock, the one just slightly farther from the Earth, ticked faster than its twin below, by an almost unimaginably tiny amount, but measurably, repeatably, exactly as the theory had said it would. Lift a clock the height of a single stair, and you lift it into a place where time flows a hair more quickly. This is not only a laboratory curiosity either. It is something your everyday life quietly depends upon. The satellites that guide you when you are lost, the ones that whisper directions to the little device in your pocket, orbit high above the Earth, far enough out that gravity is noticeably weaker there. Time runs faster for those satellites than it does for us on the ground. And the gap is large enough that if we simply ignored it, the whole system would drift into uselessness within a single day. The location it offered you would wander off by kilometers, growing worse by the hour. So the people who built it had to account for this difference, had to teach the satellites that their clocks and hours do not agree, and never will. Every time a little glowing dot finds you on a map, it is because someone took seriously the fact that gravity bends time. And if a single foot of height makes a measurable difference, imagine what happens in places where gravity is not gentle at all. Picture a world orbiting close to a black hole, one of those collapsed, impossibly dense objects where gravity grows so fierce that it bends the very shape of space. On a planet near such a thing, gravity could be so overwhelming that time would crawl. An hour spent walking on its surface might pass while years, even decades, slipped away for everyone far off in the wider universe. You could stand on that shore for what felt like an afternoon, and return to your ship to find your companions gray and weary, having waited a lifetime for you. This particular scene has been imagined in films, dramatized and stretched for the sake of a story, but the physics underneath it is entirely sound. Near enough to enough gravity, time really would slow that dramatically. The closer you drift to something truly massive, the more thickly time seems to pool around you until it very nearly stops. There is something quietly humbling in this. We think of time as the one thing that is fair, the one current that runs the same for kings and for sleepers, for the rich and the poor, the same 60 seconds in every minute for every soul alive. But it isn't fair, and it isn't fixed. The ground beneath you is forever editing the pace of your life, slowing it where the earth pulls hardest, loosening it where the pull falls away. Even now, the blood in your feet is moving through time, a fraction more slowly than the thoughts in your head. Your heart, lower down, aging ever so slightly less than your sleeping mind, simply because it sits a little closer to the center of the world. It is far too small a thing to ever notice. Over an entire human life, it adds up to less than the blink of an eye. But it is real. and there is a strange comfort in it. In knowing that the solid floor beneath your bed, the thing you trust to hold still and hold you up, is also in its silent and patient way gently slowing your passage through time, cradling you a heartbeat behind the ceiling above and the sky above that, and the satellites drifting faster through the dark, far overhead. Right now, passing silently through your body, there is a gentle rain falling that should never have reached you at all. You cannot see it or feel it. It does no harm. But all through the night, from every direction in the sky, tiny particles are drifting down through the roof, through the ceiling, through you and your bed and the floor and the ground beneath, on their way into the heart of the earth. They are called muons, and they are born high above your head. And the story of how they survive the fall is one of the loveliest proofs we have that time is not quite what it seems. It begins far up at the top of the sky. The earth is constantly being showered by tiny, fast-moving fragments from deep space. Pieces of broken atoms flung out by exploding stars and other violent events scattered across the galaxy. When one of these slams into the very top of our atmosphere, dozens of kilometers above the ground, it shatters the air it strikes and creates a little spray of brand new particles. Among them are the muons. They come into being up there, near the edge of space, and they come into being already moving downward fast, almost as fast as light itself. Now here's the trouble. A muon does not last long. Left to itself, it falls apart almost as soon as it is made. It survives, on average, for about 2/millionths of a second, and then it is gone, dissolved into other things. That is its whole natural lifespan. The blink of a blink. And in 2/millionths of a second, even moving at nearly the speed of light, a muon could only travel a few hundred meters before its time ran out. A few hundred meters, but it is born more than a dozen kilometers up, many, many times farther than that from the ground. By every reasonable expectation, by the simplest arithmetic, not a single one of them should ever reach the surface. They should all wink out high in the air long before they get anywhere near you, like raindrops evaporating before they ever touch the earth. And yet they arrive, in enormous numbers. They pour down through the atmosphere and through the rooftops and through our resting bodies every second of every day, far more of them surviving the journey than should ever be possible. We catch them in detectors. We count them. They are absolutely, unmistakably here. How? The answer is the same gentle truth that slows a clock on a moving ship. Because the muons are traveling so close to the speed of light, time itself slows down for them. That 2/millionths of a second lifespan is measured by their own internal clock, and their clock is running slow, dramatically slow, stretched out by their tremendous speed. From our point of view, watching from the ground, each muon lives far longer than it should. Its brief life dilated and drawn out until it lasts just long enough to complete the fall. The little clock that counts down its life is simply ticking more slowly than ours. There is another way to see it too, from the muon's own point of view, and it is just as strange and just as true. From where the muon sits, it is not living any longer than usual at all. Instead, the world rushing up to meet it is squeezed. The entire thick blanket of the atmosphere, all those kilometers of air, is compressed by its speed into a thin layer it can cross easily in the short time it has. One way of looking at it stretches the muon's time. The other shrinks the muon's distance. Both are correct. both deliver the same quiet miracle. The particle that should have died in the upper air instead drifts all the way down to the ground. And the wonder of this is how ordinary it is. This is not a delicate experiment performed once in a sealed laboratory under perfect conditions. This is happening everywhere, constantly, over your whole life and everyone's, over every field and ocean and city and sleeping house on Earth. The proof that time bends with motion has been falling softly out of the sky since long before there were any people to notice, since before there was a single eye to look up. The universe has been quietly running this demonstration over our heads for billions of years, asking nothing, explaining nothing, simply letting its time-stretched rain drift down through everything, on and on in the patient dark. So as you lie here now, settling deeper, let yourself picture it, not as something to fear, but as something almost tender. An invisible, weightless drizzle of tiny travelers, each one carrying a little stretched bubble of slowed down time, passing straight through you without a sound, through your blankets and your resting body and the bed and the floor, falling and falling toward the center of the world. Harmless and constant and strange all night long. The word now does not mean quite the same thing for you as it does for someone walking past your window. We carry an unshakable feeling, all of us, that there is a single present moment, one universal now, shared by everything in existence. This instant, the one you are in, feels as though it must be the very same instant for the stars and the oceans and the person on the far side of the world. Time, we assume, moves forward together everywhere, one great wavefront of now sweeping through the whole universe at once. But it isn't so, and the truth is far stranger and far softer than that. It turns out that whether two events happen at the same time depends on how you are moving. Two things that happen together at the very same moment from your point of view can happen at clearly different moments from the point of view of someone moving past you. Not because anyone's clock is broken or anyone is mistaken, but because the universe simply does not hand out a single shared definition of at the same time. There is no master clock hanging at the center of everything, ticking out one instant for us all to share. Each observer, depending on their motion, slices up time into now and not yet along a slightly different line. Over the small distances and slow speeds of an ordinary life, the difference is far too tiny to notice. You and the person walking past you disagree about what counts as now by an amount so impossibly small it could never matter. Your shared present feels perfectly solid, and for all practical purposes, here on this one small planet, it is. But stretch the idea out across the vastness of space, and it grows teeth. Imagine a galaxy far away, millions upon millions of light years off in the dark, a great spiral of hundreds of billions of stars. And imagine two people here on Earth on an ordinary street, passing each other on the pavement. One is strolling slowly in the direction of that distant galaxy. The other is strolling just as slowly, the opposite way. They are walking at a gentle human pace. Nothing remarkable, nothing fast. And yet, because of their opposite motions, their two definitions of now, when extended all the way out to that faraway galaxy, do not line up. For the one walking toward it, the present moment in that distant place might include events that, for the other walker, still lie in the future, days away from happening yet. The same instant, here on this quiet street, can correspond to two different days in a galaxy across the universe. simply because two people strolled past each other in opposite directions. It is worth saying clearly what is solid here and what is still argued over, that the timing of distant events depends on your motion, that simultaneity, as it's called, is relative, is settled, tested physics, as sure as anything we know. What it ultimately means about the nature of time, about whether that distant future is in some sense already real and waiting, is a deeper question that thoughtful people still turn over and disagree about quietly to this day. The mathematics is certain, the meaning is still a held breath. But even setting the deepest questions aside, the simple fact is enough to quiet the mind. There is no single now. The cozy feeling that all of existence is marching forward together, in step, sharing one present heartbeat. That feeling is a local comfort, true enough on the scale of a room or a street or a planet, but not a law written into the universe. Out there, across the great distances, the present frays and splits and bends with every motion. Two people can stand side by side and have, woven invisibly through the cosmos around them, two different ideas of what is happening right now in the far reaches of the sky. It might sound unsettling, but I think there is a strange peace in it. The moment you are in, this one here with the dark gathered soft around you, is genuinely, particularly yours. Not a slice of some universal instant imposed upon everyone, but your own present, cut at your own gentle angle through the fabric of time. No one passing by, no distant star, no faraway world is obliged to share it. Your now is yours alone, and so the universe keeps no central clock. It lets each of us carry our own quiet sense of the present through the dark, never quite agreeing, never needing to. A great soft scattering of nows, drifting along together and apart, all at once, beneath the same unhurried stars. What if the past has not gone anywhere? We feel so deeply that we rarely even think to question it, that the past is gone, vanished, used up and dissolved. The morning you woke to as a child, the face of someone you loved who is no longer here, the exact way the light fell across a room on some ordinary afternoon years ago. All of it feels utterly lost, swept away by the steady forward motion of time, leaving only memory behind. And the future, by the same feeling, does not exist yet. It is a blankness, and not yet, waiting to be made real one moment at a time. But there is a way of understanding time, taken seriously by many thoughtful physicists, though by no means all of them, in which none of that is quite right, in which the past is not gone and the future is not blank, in which all of it, every moment that ever was or ever will be, exists fully and equally right now. It is sometimes called the block universe. The idea is this: that time is not a moving spotlight, sweeping forward and leaving darkness behind it. Instead, all of time, every instant, from the deep past to the far future, exists together, all at once, like a vast and finished landscape. Picture the whole of history laid out not as a river flowing, but as a long, still sculpture. Or think of a film. When you watch a film, it feels as though the story is unfolding moment by moment, the present scene the only one that is real. But every frame of that film already exists, complete, wound up on the reel. The ending is just as real as the beginning. Nothing is being created as you watch. You are simply moving through what is already there. In this view, your life is something like that. Not a candle burning down, but a long shape stretched out through time, with your birth at one end and your final breath at the other. And every laugh, and every quiet evening, and every ordinary Tuesday existing all along its length, equally real, equally there. The child you were has not been erased. That morning still exists in its own place in the great landscape of time. You have simply moved on from it, the way you move on from a room you have left. The room is still there. You are only no longer standing in it. This is not an idle daydream. It grows, quite naturally, out of what we have learned about time being personal and stretchable, out of the discovery that there is no single, universal present moment shared by all of existence. For if your now and someone else's now can genuinely differ, can slice through the universe at different angles, then it becomes very hard to say that only the present is real, because there is no single present that everyone agrees on. It begins to seem more honest to say that all the moments are equally real, and that now is simply wherever any given observer happens to be standing in the great fixed landscape of time. But I want to be careful and honest with you here, in the quiet. This is an interpretation, not a settled fact. It is one way of making sense of what we know, a deeply considered one, held by many serious people, but not the only way. Others argue, just as thoughtfully, that only the present is truly real, and that the past really is gone, and the future genuinely open. The equations of physics do not force the matter one way or the other. What you are hearing now is not a measurement, like a slowed clock or a falling particle. It is a question about what it all means, and that question is still gently, genuinely open. And yet there is something that settles the heart about even the possibility. If the block universe is the way things truly are, then nothing that has ever happened is truly lost. Every tender moment, every person you have loved, every version of yourself you have ever been, the sleepy child, the restless youth, the one lying here now in the dark, all of it still exists, somewhere along the great unbroken shape of time, as real and as solid as this present instant. The past would not be a thing that has been destroyed. It would only be a place you can no longer reach, out of sight, out of touch, but never gone. It is a strange and lovely thought to carry down into sleep, that perhaps time does not erase anything at all, that perhaps every moment simply is forever in its own quiet place, and that you are not a flame slowly burning out, but a long, complete, luminous thing, stretched gently across the whole of your life, present in all of it at once, even now. A cup slips from your hand and shatters on the floor, and you have never once in your entire life seen the pieces leap back up and gather themselves whole again. This is so obvious that it feels almost foolish to point out. Of course, the cup does not reassemble. Of course, the smoke does not pour back into the candle. The ripples do not rush back to the center of the pond. The milk does not unswirl itself from the coffee and rise back into the jug. Time runs one way. Everyone knows this. We feel it in our bones. The past behind us, fixed and finished, the future ahead, open and unknown, and ourselves carried always forward, never back. But here is something that should genuinely astonish you. Here in the stillness, according to the deepest laws we have ever found for how the universe works, this one-way flow should not exist at all. When physicists write down the most fundamental rules, the laws governing how the smallest pieces of matter move and push and pull on one another, those laws look exactly the same whether time runs forward or backward. They have no built-in sense of direction. If you could film the dance of two particles colliding and bouncing apart, and then play that film in reverse, what you would see running backward would also be a perfectly legal, perfectly possible event under the laws of physics. At the smallest scale, the level of individual particles, the universe simply does not distinguish between past and future. The rules work just as well either way. And yet, all around us, at the scale of cups and candles and living bodies, time has an unmistakable arrow. It points one way and one way only. So where does it come from? If the underlying rules don't care about direction, why does the world we actually live in care so deeply, so completely, that we cannot even imagine it otherwise? The answer we have found is one of the great pillars of science, and it turns on a quiet idea called entropy, which is more or less a measure of disorder, of how spread out and mixed up and jumbled things are. And there is a law, as reliable as any we know, that says this disorder almost always increases. Things fall apart, things mix together. Heat flows from the warm into the cold and spreads itself thin. Order crumbles into disorder, and the reverse essentially never happens on its own. The reason is, in a way, simply a matter of counting. There are so very many ways for things to be jumbled and disordered, and so very few ways for them to be neat and ordered, that the universe, left to chance, tumbles overwhelmingly toward the messy. A shattered cup can lie in countless scattered arrangements. A whole cup can be whole in only a few. And so the cup breaks and stays broken, not because some law forbids it from ever reassembling, but because the odds against it are so staggering that it never, in all the long age of the universe, simply happens. The arrow of time, then, is the direction in which disorder grows. But this only pushes the wonder one step deeper to a question that remains genuinely, achingly open. For disorder can only increase if things began in an ordered state in the first place. The river of time only runs downhill because, somehow, it started high. And so the real mystery is this: why did the universe begin in such an extraordinarily neat, smooth, low disorder state? A state so unimaginably orderly that everything that has happened since, all the structure and the complexity in the life, has been the long, slow unwinding of it. We do not know. This is not a settled thing. It is one of the deepest open questions in all of physics. Why the beginning of everything was so quiet and so ordered, so perfectly poised at the very top of the hill that 14 billion years of tumbling have not yet brought it to rest. Some of the finest minds alive are still turning it over. The arrow of time may be, in the end, less a law of nature than a kind of memory. A faint and lasting echo of how astonishingly ordered everything was in the very first moment. There is a gentleness in that thought, I think. The reason you cannot go back, the reason the broken cup stays broken and the past stays past, is not some harsh rule pressing down on the world. It is simply that everything is very slowly, very softly spreading out, settling, cooling, coming to rest from a beginning of almost unbelievable order. You are living inside that long unwinding. So is everything. The stars are doing it, scattering their warmth into the cold of space. The coffee does it in your cup every morning. And tonight, as you let go of the day, you are part of that same vast and patient drift, the whole universe, and you within it, easing gently, irreversibly, towards stillness. Hidden inside our finest theory of gravity, there's a doorway. It is the idea of a wormhole, a tunnel through the very fabric of space, a shortcut that could in principle join two places impossibly far apart, or even two different moments in time. It is not something anyone has ever seen, but it is not pure invention either, not in the way dragons are. It emerges on its own, straight out of the mathematics that describes how gravity bends space and time. The very same mathematics that in every test we have ever made has turned out to be true. To picture how such a thing could even be possible, you have to let go, gently, of the idea that space is just empty nothing, a fixed, rigid stage on which everything else happens. Our best understanding tells us that space is not like that at all. Space is more like a fabric. It can stretch, it can curve, it bends around heavy things, sags beneath the weight of stars, and that bending is exactly what we feel as gravity. The earth holds you to your bed, not by reaching out and pulling on you, but by gently curving the space around itself, so that the most natural path for you to take leads downward into the soft mattress beneath you. And if space can bend, then in principle, it can bend a great deal. It can fold. Imagine the whole of space as an enormous sheet, and imagine two distant points on that sheet. Two places separated by an unthinkable gulf, light years and light years apart. Now imagine the sheet folding over gently until those two faraway points come to rest almost touching, one just above the other. A wormhole would be a kind of bridge stitched between them at that fold, a short tunnel connecting the two distant points directly, so that you could step into one mouth and out the other. Having crossed in a few paces a distance that light itself would take an age to travel. And here is where it touches our question tonight. Because space and time are woven together into a single fabric, a wormhole need not only connect two distant places. Its two mouths could, in principle, sit at two different times. Step into one end, and you might emerge from the other, not only somewhere far away, but somewhen far away, in a moment that has already passed, or one not yet arrived. A tunnel not just through space, but through time itself. But I want to be honest with you, here in the quiet, about how much of this is real and how much is still only the mathematics dreaming. No wormhole has ever been found. We have never seen one, never detected the faintest sign of one anywhere in all the sky we have ever searched. They are permitted by the equations, but permitted is not the same as present. And even if one did exist, there are deep and stubborn problems. A natural wormhole left to itself would be desperately unstable. It would form and collapse in less than an instant, snapping shut faster than anything, even light, could pass through it. To hold such a tunnel open long enough to cross would require something very strange indeed. A kind of matter or energy unlike anything we handle in ordinary life, something that pushes outward against the collapse, something we are not even certain can exist in the amounts you would need. The door, in other words, may be drawn into the blueprint of the universe, and yet may be impossible to ever actually open. And still, there is something quietly thrilling in knowing that the door is even in the plans, that when the greatest minds sat down to write the laws of gravity, working only from careful thought and careful measurement, the equations they uncovered turned out to contain, without anyone putting it there on purpose, the faint mathematical ghost of a tunnel between distant times. The universe did not have to be that way. It could have been built so that no such thing was even imaginable. Instead, the possibility is woven right into the deep structure of space and time, waiting whether or not it can ever be reached. So let the thought rest lightly as you drift. Somewhere in the pure mathematics of gravity, there is a tunnel, two doorways far apart in space and perhaps in time, joined behind the scenes by a fold in the fabric of everything. We may never find one. We may never build one. But the shape of it is there, sketched faintly into the laws of the cosmos. A quiet, beautiful maybe, folded into the dark, holding open the smallest possibility that distant moments are not quite as far apart as they seem. There may be a kind of energy in this universe that weighs less than nothing at all. It sounds like a contradiction, like a riddle with no answer. We think of empty space as the floor, the bottom, the very least there can possibly be. Nothing is nothing. Surely you cannot have less than empty. And yet our deepest physics suggests there are places where space can hold less energy than empty space does. Small pockets that are, in a strange and precise sense, emptier than empty. Physicists call the stuff of such places negative energy, or sometimes exotic matter, and it is one of the most peculiar and important ideas in the whole question of whether time travel could ever be possible. It matters because nearly every serious idea for traveling through time runs sooner or later into the same wall. And this strange energy is the only thing anyone can imagine that might break through it. To hold open a tunnel through space-time, to keep the fabric of the universe folded back on itself rather than snapping flat again, you would need something that pushes outward, something that props the door against its own collapse. Ordinary matter cannot do it. Everything we handle in daily life, stone, water, starlight, our own warm bodies, has positive energy, and positive energy pulls space inward, helps it close. Only this hypothetical negative energy, this less than nothing, could push the other way, holding the impossible door ajar. Without it, the tunnel stays shut. With it, perhaps, they might just open. And here's the wonderful part. The part that lifts this out of pure fantasy. We have already seen a flicker of it. We have already, in real laboratories with real instruments, created a tiny region of space that holds less energy than empty space. It comes from a delicate and beautiful phenomenon called the Casimir effect. To picture it, imagine two flat metal plates, smooth as mirrors, uncharged, perfectly ordinary, placed in a vacuum and brought very, very close together until only the thinnest sliver of space separates them. Now, empty space, it turns out, is never truly empty. Even the purest vacuum is quietly humming with faint, restless energy, a constant soft fizz of activity at the smallest scales, far too subtle for us to ever feel. But when you bring the two plates close enough together, they change the fizz between them. They quiet it. Fewer kinds of that restless energy can fit in the narrow gap than can exist in the open space outside. And so the region between the plates ends up holding less energy than the emptiness around it. The plates are gently pushed together by the difference, by the fuller emptiness outside pressing in against the quieter emptiness within. And that quieter region, that hush between the plates, is a genuine pocket of negative energy. We have measured the push. It is real. It is here. But I want to set your expectations gently and honestly. What we can make is real, but it is almost unimaginably small. A faint whisper of negative energy in a sliver of space narrower than you could ever see. To hold open a tunnel large enough for a person to pass through, to bend time on any scale that could possibly matter, you would need this strange energy in staggering amounts, gathered and shaped in ways that may simply not be possible. There are hints, woven into the laws of physics themselves, that the universe permits only the faintest traces of negative energy and no more. that it lets you borrow a little, briefly, but never enough, to build a doorway through time. Whether those limits are absolute, whether some clever arrangement could ever gather enough, we do not yet know. It remains an open and genuinely uncertain question. And yet I find there is something quietly marvelous in even the little we have found. The universe, it seems, keeps a small amount of less than nothing tucked into its pockets. In the silent gap between two close-set plates, in the hush of a near-perfect vacuum, there is a place where emptiness runs deeper than empty. A tiny, real proof that the floor we thought was the bottom has a faint hollow beneath it after all. It may never be enough. The door may stay forever closed for want of enough of this strange, weightless stuff. But the door's one true requirement turns out not to be pure imagination. It exists in trace amounts in the quiet dark of a vacuum chamber, and perhaps in tiny flickering pockets throughout the whole of space, all around you now. Little hushed hollows in the fabric of the world, emptier than empty, soft and strange and real. In 1949, a quiet and brilliant mathematician handed Albert Einstein an unusual birthday gift. A universe in which you could travel into your own past. The mathematician's name was Kurt Gödel, and he was one of the most extraordinary minds of his century. He and Einstein were close friends in the last years of Einstein's life. The two of them used to walk home together through the trees, deep in conversation, two old men murmuring about the deepest things there are. And for Einstein's 70th birthday, Gödel gave him not a wrapped present but a piece of mathematics, a new and perfectly valid solution to Einstein's own equations of gravity. A solution that described a very strange universe indeed. Einstein's great theory of gravity is, at its heart, a set of equations describing how matter and energy bend space and time. Feed different arrangements of matter into those equations, and they describe different possible universes. Gödel fed in a universe that was, as a whole, slowly rotating, the entire cosmos turning gently, like a vast and silent wheel. And when he worked out what such a rotating universe would actually be like, he found something that astonished even him. In Gödel's universe, time does not simply run in a straight line from past to future. The rotation of the whole cosmos drags the very fabric of time around with it, twisting it until the paths through space and time can curl back upon themselves. There exist in such a universe what are called closed loops in time, paths that, if you followed them far enough, would bring you back not just to where you started, but to when you started. You could set out from a given moment, travel along such a loop, never once going faster than light, never doing anything that felt strange or forbidden along the way, and arrive at the end of your journey at an earlier moment of your own life. You could, in the most literal sense the words allow, return to your own past. Now I want to be clear and honest with you, softly here in the dark. Gödel's universe is almost certainly not our universe. When we look out at the cosmos around us, we see no sign that it is rotating in the way his solution requires. As far as we can tell, the real universe simply does not spin like that. And so these particular loops in time are not lying out there somewhere, waiting for us to find them. This is not a map to a time machine we could go and use. But that was never quite the point, and it does not lessen the wonder. Because what Gödel proved beyond any doubt was something profound. He proved that the laws of gravity, our deepest and best tested understanding of space and time, do not, by themselves forbid travel into the past. The equations permit it. Tucked away inside the very mathematics that governs falling apples and orbiting moons and the slow bending of starlight, there is room, genuine, rigorous mathematical room, for time to curl back on itself. Einstein, by all accounts, was deeply unsettled by this gift. He had built the theory. He had not realized it held such a thing inside it, and he never fully made his peace with it. This is the thought I would leave you with as you drift towards sleep. We tend to imagine that the strangeness of time travel is something invented, dreamed up by storytellers, bolted on from the outside, having nothing to do with the real and serious laws of nature. But it isn't so. The strangeness was already there. It was hiding, quietly, inside our finest theory of how the universe is built, long before anyone went looking for it. A friend gave it to Einstein for his birthday, written in equations, and it has never quite gone away. So let yourself picture Gödel's gentle, impossible cosmos, a whole universe turning slowly and silently, like an enormous carousel of stars in the dark. And somewhere upon it, a path, a long, looping path that breaks no law and exceeds no speed, that you could follow at an easy and unhurried pace, winding out through the turning sky and curving softly all the way back around, until it returns you at last to a younger morning you thought was gone forever. We may never walk it. It may not exist anywhere in our sky, but the laws of the universe, it turns out, left the door quietly unlatched. Imagine two threads, each thinner than the smallest piece of any atom, and each so heavy that a single mile of one could outweigh a mountain. These threads have a name, cosmic strings, and they may not exist at all. But if they do, they would be among the strangest objects in all of creation. And two of them, racing past each other in the dark, might be able to bend time into a circle. Let me tell you what they are, or what they would be, in the very first moments after the universe began. In that searing, formless instant when everything was unimaginably hot and dense, the fabric of space itself may have settled and cooled unevenly, the way a smooth sheet of ice freezing fast across a pond can trap long cracks and seams within it. Some of our theories suggest that this cooling could have left behind enormously thin, enormously dense flaws running through space. Threads of pure, trapped energy, narrower than a single particle, yet so concentrated that a tiny length of one would weigh as much as a great mountain range or far more. These are the cosmic strings. They would stretch across vast distances, perhaps spanning the whole universe, whipping and trembling in the dark, left over from the birth of everything. And here's the first strange thing about them. A cosmic string with all that weight pressed into so thin a line would warp the space around it, but not in the way a star or a planet does, drawing things gently inward. Instead, a cosmic string would do something stranger. It would take a tiny wedge out of the space around it, as if you had cut a thin slice from a circle and then pressed the two cut edges back together. The space surrounding the string would be shaped a little like a cone. Walk all the way around the string, and you would find you had traveled slightly less far than you should have, as though a small piece of the world had quietly gone missing. Now, in the early 1990s, a physicist named J. Richard Gott worked out something remarkable about these objects. He imagined not one cosmic string but two, flying past each other at tremendous speed, close to the speed of light. And he found, working carefully through the equations, that the warped, folded space around two such strings could combine into a path. A great loop you could travel through space that would bring you back not just to where you began, but to a moment before you set out. By weaving the right course around the two passing strings, never going faster than light yourself, you could return to your own past. But I want to be gentle and honest with you here, in the quiet. This is theory layered upon theory. We have never found a cosmic string. Despite long and careful searching, no one has ever detected the slightest sign that they are really out there. They might exist. Some of our ideas about the early universe predict them, but they might just as easily be a beautiful possibility that nature never used. And even setting that aside, God's time loop comes with deep difficulties. Other physicists, studying his solution closely, found that arranging two cosmic strings into exactly the right configuration would seem to demand conditions that may be impossible to actually achieve, that the universe in practice might never permit such a machine to be built, even if the strings themselves were real. So this is not a blueprint. It is a possibility glimpsed in the mathematics, hedged about with doubts. And yet, there is a quiet wonder in it that I find hard to let go of. The idea is that the universe, in being born, might have left behind scraps, thin, forgotten seams from its own creation, still threaded through the dark, and that those leftover scraps, if you could find two of them and catch them at the right moment, might bend the straight line of time into a loop you could walk around. Not magic, not invention, just the strange geometry of space, folded by the heaviest, thinnest things that may ever have existed. So let the picture rest softly in your mind as you drift. Two invisible threads, older than the stars, thinner than anything, heavier than mountains, sweeping silently past one another somewhere out in the deep, and around them, traced in the warped and folded space they leave in their wake, a great gentle loop, a path that, if it is real, and if anyone could ever follow it, would carry you all the way around and quietly home, to a yesterday you thought was behind you for good. There are experiments in which a choice you make now seems to reach back and change what a tiny particle already did, moments before. It sounds impossible, like a memory rewriting itself, and I want to be careful with it, because it is one of those places where the truth is genuinely strange and the temptation to overstate it is strong. But the experiments are real, performed many times, and what they show is among the most haunting puzzles in all of physics. To feel why, you have to know one quiet, well-tested fact about the smallest pieces of the world, particles of light and of matter and of everything else. When you send a single one of these tiny things toward a barrier with two narrow openings in it, and you do not watch which opening it goes through, it behaves as if it somehow went through both at once, like a ripple spreading through both gaps and overlapping with itself on the far side. But the moment you set up any way of detecting which opening it actually passed through, the very moment that information becomes available, it stops behaving like a spread-out ripple and acts instead like a single definite speck, passing cleanly through one opening or the other. Look, and it is a particle taking one path. Don't look, and it is a wave taking both. This has been confirmed countless times. It is simply how the quantum world works. Now here's where it becomes dizzying. A physicist named John Wheeler asked a startling question. What if you waited? What if the particle had already passed the barrier, already made its journey, already, you might think, committed to being a wave or a particle, and only then, at the very last instant, did you decide whether or not to detect which path it had taken. And when this was actually done, in careful and ingenious experiments, the answer was this. The particle's behavior matched the choice that was made after it had already gone through. Choose at the last moment to learn the path, and you find it had behaved as a single particle on one path all along. Choose at the last moment not to learn the path, and you find it had behaved as a spread-out wave through both. It is as though the particle did not settle the question of what it had done until the choice was finally made. As if the present reached gently back and shaped the past. But here's what I must tell you plainly, my friend, so that the wonder stays honest. Almost all physicists agree that nothing actually travels backward in time here. No message, no signal, no influence races into the past. You cannot use this to send a single word to yesterday. The strangeness only ever appears when you gather all the results together afterward and compare them. The universe never lets you catch it in the act, never lets you change anything you could have known beforehand. What the experiment truly unsettles is not the order of time, but our idea that a particle has a definite finished history at all before the whole story is told. The past is not being rewritten. It is perhaps that for the very smallest things, the past was never quite as settled as we imagined. And that, I think, is the deeper marvel. Gentler than time travel, and stranger. We carry an assumption so deep we never even name it, that the world has already happened, definitely and completely, moment by moment, whether or not anyone is watching. But down at the smallest scale, the quantum world seems to resist this. It seems to hold its possibilities open, soft and unfixed, not fully deciding what occurred until the last question has been asked. It is not that the future controls the past. It is that, in some quiet way, we still do not fully understand. The story and its telling are more tangled together than they have any right to be. So let that settle over you as you rest. A single speck of light sent toward two open doors in the dark, and somehow not yet having chosen, not yet having needed to choose, which way it went, or whether it went both, until the very last gentle moment. The world at its smallest, waiting patiently to be asked, and nothing, anywhere, ever quite as finished as it seems. Imagine you travel back in time, and by pure accident you prevent your own grandparents from ever meeting. It is the oldest and most famous puzzle about time travel, and it cuts straight to the heart of why the whole idea is so troubling. If your grandparents never met, then one of your parents was never born. And if that parent was never born, then neither were you. But if you were never born, then you could never have grown up, never have built a time machine, never have traveled back to keep your grandparents apart in the first place. So the thing that prevents your birth could only happen if you were born. It is a knot that cannot be tied, a door that locks itself with a key that no longer exists. This is what people call the grandfather paradox. And you do not need to imagine anything so dramatic as your own family to feel its force. Step back into yesterday and move a single pebble, and you have changed the past. But the past is the very thing that produced the present you came from, including your decision to travel and the pebble you moved. Change the cause, and you begin to unravel the effect that did the changing. The logic eats itself. And unlike most of the wonders we have wandered through tonight, this one is not a fact about the universe that we have measured. It is something simpler and harder, a problem in pure reason. It suggests that travel into the past, however the equations might seem to allow it, may run headlong into a wall. Not of physics, but of logic itself. People have wrestled with this knot for as long as they have dreamed of time travel, and they have imagined a few ways it might come undone. Perhaps some have thought the past simply cannot be changed, that if you went back, you would find that everything you did had somehow always been part of how things happened. Every attempt to alter events quietly folding into the story rather than breaking it. Perhaps others have wondered, changing the past would not unmake your world at all, but split off a new and separate one, leaving your own history untouched. Or perhaps the knot is telling us something blunt and final, that travel into the past is simply impossible, forbidden, a door the universe keeps permanently shut. These are not answers we can test. They are different ways of refusing to let logic tear itself apart. I want to be clear about what kind of thing this, here in the soft dark. The grandfather paradox is not a discovery, like a slowed clock or a bending ray of starlight. It is a thought, a perfectly sharp, perfectly stubborn thought, about what would have to be true if the past could be reached and altered. It does not prove that time travel is impossible, but it does show, with the cold clarity of pure reasoning, that backward time travel and the freedom to change what we find there cannot both be true at once. Something has to give. Either the past is closed to us, or it is closed to change, or reality is far stranger than a single unbroken history. And there is, I think, a strange comfort buried in the puzzle. We so often wish we could go back, to mend something, to say the thing we did not say, to take a different turn. The grandfather paradox whispers that perhaps the past is not ours to rewrite, and perhaps that is not a cruelty, but a kind of mercy. What has happened is held safe exactly as it was, beyond the reach of our second guessing. The pebble stays where it fell. The words stay as they were spoken. The whole long chain of how you came to be lying here tonight remains unbroken. Every link in its place, because it must, because you are here. And that is its own quiet proof that the past held. So let the puzzle rest, unsolved and gentle as you drift. A sunlit street in some year before you were born. You, standing in it, knowing that to shift even one small thing might unmake the very person who came. And the past all around you holding firm, not because it is forbidden to touch, but because somehow it already knows how the story goes. Imagine a notebook that no one ever wrote. A traveler carries it back through time and gives it to a young composer. The composer studies the music written inside, copies it out, and is celebrated for the beautiful symphony it contains. Years later, that very notebook, the published, finished music, is picked up by the traveler, who carries it back through time and gives it to the young composer. Around and around it goes, the notebook passing from future to past to future again, forever. And so we have to ask a question that has no answer. Who actually composed the music? The composer only copied what was already in the notebook. The notebook only contains what the composer was given. The melody exists, lovely and complete, but at no point did anyone ever create it. It simply is, looping endlessly, with no beginning. This is sometimes called the bootstrap paradox, and it is a gentler, stranger cousin of the more famous puzzles about changing the past. It does not tie itself into a contradiction the way some do. There is nothing logically broken here, no event that prevents itself from happening. The loop is perfectly self-consistent. The notebook is given, copied, published, and carried back smoothly with no step undoing another. And that is exactly what makes it so unsettling. It could happen in a universe that allowed travel into the past without breaking a single rule. It only breaks something quieter and deeper, our certainty that everything must come from somewhere. For we believe, without ever quite saying it aloud, that everything has an origin. Every song was written by someone, somewhere, for the first time. Every idea was thought of once before it was thought of again. Every object was made. Every story was begun. We assume that if you trace anything far enough back, you will find its first moment, the instant it came into being out of something that was not yet it. But a loop in time would allow things that have no such moment. Information that was never invented. An object that was never built. A melody that was never by anyone first imagined. It would not come from the future exactly, nor from the past. It would simply circle between them, uncreated, existing only because it already exists. Picture it with something other than music, if you like. A traveler learns the design of a machine, journeys into the past, and hands the plans to the very inventor who is one day said to have first dreamed it up. The inventor builds it, the design enters the world, and in time the traveler reads those same plans and carries them back. The machine works. It is real. You could hold it in your hands. And yet the spark of insight behind it, the original act of invention, never happened anywhere. There was no first inventor. Only the plans, going round and round, building the very thing that contained them. I want to be honest with you about what this is, softly, here in the dark. The bootstrap paradox is not something we have ever seen, and it could only arise if travel into the past were truly possible, which, as you know, remains deeply uncertain. It is a thought, a riddle, a way of poking gently at one of our deepest assumptions to see whether it really must hold. It breaks no law of logic. It simply asks, does everything truly need a beginning? And it offers as its answer a quiet and disconcerting maybe not. There is something almost dreamlike in the idea, and dreams are a fitting place for it. We are so used to the long chain of cause leading to cause, each thing born from the one before it, stretching back and back toward some first cause we can scarcely imagine. The bootstrap paradox sets, beside that long chain, a small and perfect circle, a loop of cause and effect with no first link. A ring with no clasp, no place where it was joined, turning quietly on its own, having always turned. So let yourself rest on that image as sleep draws near. A notebook worn soft at the edges, full of music that is genuinely beautiful and genuinely real, and that no hand ever first set down, passing gently from one pair of hands to another, across the years, around and around, complete in itself, owing its existence to nothing but its own endless return. Not made, not begun, simply somehow always there, like a melody you cannot quite remember learning, humming faintly in the dark, that seems to have been with you all along. Perhaps the universe will simply never let you create a contradiction. It is one of the most elegant ideas anyone has offered for how travel into the past might be possible without tearing reason apart. And it goes by the name of the self-consistency principle, first set out carefully by the physicist Igor Novikov. The idea is disarmingly simple, and the more you sit with it, the deeper it goes. It says this: if travel into the past can happen at all, then the only journeys that can actually occur are the ones that fit perfectly into history as it already was. You cannot change the past, not because some force stops you at the last second, but because anything you do back there was always already a part of how things turned out. To see how strange and how reasonable this is at once, physicists imagined a small, clean example, not people and grandparents, but something as plain as a billiard ball. Picture a ball rolling toward a kind of tunnel through time, a hole that would send it into the past, where it emerges a little earlier and rolls along, and where it might strike its own earlier self, knocking that earlier ball off course so that it never reaches the tunnel at all. There it is again, the familiar knot. The ball stops itself from ever making the journey that let it stop itself. But when they worked through the mathematics carefully, they found something quietly astonishing. There were always other paths the ball could take, paths that were fully consistent. In these, the ball comes back through time and strikes its earlier self. Yes, but instead of knocking it away from the tunnel, the gentle nudge is exactly what sends the earlier ball into the tunnel in the first place, at precisely the right angle to come back and deliver that very nudge. The collision does not prevent the journey. The collision causes it. Everything fits, the loop closes smoothly, with no contradiction anywhere within it. And this, the principle suggests, is how it would always go. If you traveled back meaning to change something, to undo a sorrow, to stop a meeting, to alter the course of your own life, you would find somehow that you could not. Not because you were frozen or forbidden, but because only the consistent version of events is physically allowed to happen at all. The gun would jam. Your hand would slip. You would arrive a moment too late, or change your mind, or discover that the very thing you did was what brought about the outcome you had hoped to prevent. Every road that leads to a contradiction is simply closed. Only the roads that loop back on themselves without breaking can be traveled. I want to be honest with you softly about the standing of this idea. It is a conjecture, a proposal, beautifully reasoned, but not a proven law. We cannot test it because we have no time machine to test it with. It is one possible way the universe could permit visits to the past while keeping logic intact, and many thoughtful people find it the most graceful answer of all. But it carries a strange weight with it, a question it cannot quite escape. For if only consistent histories can happen, then a traveler in the past would not truly be free. Every choice they made would have to be exactly the choice that history required. They could visit the past, but only ever as someone already woven into it, doing precisely what they had always done. There is something both unsettling and oddly peaceful in that thought. It suggests a universe that does not need to police itself, that has no need for forbidden zones or sudden interventions, because the very fabric of what can happen simply does not include contradiction. Things hang together. The story holds, not because anything forces it to, but because only the versions that hold are real. A traveler to the past would be less an intruder than a thread, slipping into a tapestry that already had a place for them, filling exactly the gap they had always filled. So let that settle over you as you sink towards sleep. A small ball rolling through the dark, falling into a tunnel in time, circling back to meet itself. And instead of breaking everything, nudging itself gently, perfectly onward into the very journey it has just completed. A loop with no contradiction in it anywhere. A past that cannot be changed, not because it is guarded, but because it was, all along, exactly the way it was always going to be. Maybe you could change the past after all, and the only thing it would cost you is the world you came from. There is an idea in physics, strange and serious in equal measure, that offers a way out of every paradox of time travel at a single stroke. It comes from one of the boldest interpretations of the quantum world, and it says, quietly, that ours is not the only history. That reality is not a single thread running from past to future, but something more like an endlessly branching tree. The idea grows out of a deep puzzle in the physics of the very small. Down at the level of individual particles, the world does not seem to settle on single, definite outcomes the way our everyday experience does. A particle faced with two possibilities seems in some sense to explore both at once. And one way of making sense of this, taken seriously by a good number of physicists, though by no means all, is to say that both outcomes truly happen. That at every such moment, reality quietly divides, branching into separate worlds, one for each possibility, each just as real as the others, each carrying on entirely unaware of the rest. In this view, there is not one universe but a vast and ever-growing forest of them, splitting and splitting again with every passing instant, every world a complete and genuine history of its own. Now imagine in such a reality that you travel into the past. According to this picture, worked out carefully by the physicist David Deutsch, you would not return to your own past at all. You would arrive in a branch, a parallel version of history, real and solid, but not the one you remember. And there, you would be free. You could change anything. You could prevent a meeting, alter a choice, even keep your own grandparents apart, and no paradox would follow. Because the world you changed would not be the world you came from. In that branch, a version of you is simply never born. But you, the traveler, were born in a different branch, where everything happened just as it always did. You did not unmake yourself. You stepped sideways into a history that forks away from your own and never rejoins it. And so in this single idea, the great knot quietly comes undone. There is no contradiction, because there is no single past to contradict. The grandfather you might prevent from meeting your grandmother belongs to a different branch than the one that produced you. Both versions are real. Both go on. You could no more erase yourself than you could erase a person in another room simply by closing your eyes. Travel to the past in this picture is not a loop that strangles itself, but a doorway into a neighboring world, one you can enter and shape, but never quite return from, because the branch you left has carried on without you. I want to be honest with you here in the soft dark about how much of this is solid. The idea that reality branches into many worlds is a real and respected interpretation of quantum physics. But it is an interpretation, not an established fact. We cannot, at present, see these other branches or prove they are there. Other thoughtful physicists understand the same puzzles in very different ways. And applying the idea to time travel is more speculative still. A thought built upon a thought. So this is not something we know. It is something we can imagine carefully as one possible shape the truth might take. But what a shape it is to rest your mind upon. It would mean that every path not taken is taken somewhere. That all the choices you have ever turned away from are being lived out fully and really in worlds branching softly off from your own. It would mean the past you long to revisit is not lost so much as it is one branch among countless others, each as real as this one. And it would mean that to change what has been would not be to destroy it, but only to set out into a new history, leaving the old one safe and whole behind you. So let the picture drift over you as sleep comes near. A great tree of worlds, silent and vast, branching and branching in the dark, every moment a gentle fork, every possibility a living branch, the whole immense forest of what might be growing quietly in every direction at once. And you here, on this one branch among the numberless many, settling into the particular night that is yours. While somewhere, on 1,000 other branches, 1,000 other versions of you are settling too, into 1,000 quiet nights beneath 1,000 familiar scattered stars. In the cold, exact language of physics, an antiparticle looks exactly like an ordinary particle traveling backward through time. It is one of those facts that sounds like poetry and turns out to be mathematics. And it touches our question tonight from an unexpected direction. Not great machines or folded space, but the very smallest pieces of matter and a strange symmetry hidden in the equations that govern them. Let me begin with antimatter itself, which is real and which we make and study every day. For nearly every kind of particle in the universe, there exists a kind of mirror twin, an antiparticle, identical in almost every way, but opposite in certain properties, like a reflection that carries the reverse of a charge. The tiny electron, that familiar speck of matter humming in every atom of your body, has such a twin. The positron, exactly like an electron but with the opposite charge. When a particle and its antiparticle meet, they do not simply collide and bounce apart. They annihilate, vanishing together in a flash of pure energy, each unmaking the other completely. This is not speculation. We create antimatter in laboratories, store it for fleeting moments, and watch it meet ordinary matter and disappear in light. It is as real as anything in physics. Now here's the strange and beautiful part. When physicists write down the equations that describe how these particles move and interact, they find a curious symmetry buried inside. The mathematics that describes a positron, an antimatter electron, moving forward in time, turns out to be exactly the same as the mathematics that would describe an ordinary electron moving backward in time. The two descriptions are not merely similar. In the equations, they are identical. And so a way of reading the mathematics emerged, championed by physicists like Richard Feynman, in which an antiparticle simply is a particle running in reverse through time, an electron that, instead of traveling from past to future like everything we know, traces its path the other way, from future to past. This is not a fringe idea or a flight of fancy. It is woven into the everyday tools physicists use to understand the subatomic world. In the diagrams they draw to picture how particles meet and transform, a line representing an electron can turn a corner and become, heading backward in time, a positron, the same single line, the same single thing, simply changing the direction in which it travels through time. It works. It gives the right answers. It has helped build one of the most successful theories in the history of science. But I must be careful and honest with you here, softly, in the dark, because it is easy to hear this and imagine far more than it means. This is an interpretation of the mathematics, a way of reading the symmetry in the equations. It does not mean that positrons are tiny time machines, or that you could ride one back into yesterday, or that we have ever watched anything truly travel backward through time the way a story imagines it. We do not see antimatter arriving from the future. What we see are particles and antiparticles behaving exactly as the equations predict. And we notice, with a kind of wonder, that the equations do not seem to care very much about the direction of time at the smallest scale. The backward-running electron is a description that fits perfectly. Not a traveler we have caught in the act, and still, even held carefully, it stirs something. We feel time's forward flow so deeply, so absolutely, that it seems built into the very bones of reality. And yet here at the smallest scale, in the most fundamental equations we have, that forward direction grows faint and uncertain. So faint that an antiparticle moving one way and an ordinary particle moving the other become, mathematically, the very same thing. It is as though the great river of time, so wide and one-directional at our scale, dissolves at its source into something that flows just as easily either way. So let that quiet thought carry you towards sleep. Somewhere inside you, in every atom, the possibility of these mirror twins is woven into the fabric of things. And in the deep mathematics that describes them, the difference between a particle drifting into tomorrow and its twin drifting into yesterday melts away to nothing. At the smallest scale, the direction of time is less a wall than a whisper. And perhaps there's a gentleness in knowing that the forward rush we feel so surely is not, at the very bottom of things, as fixed and absolute as it seems. That down where the world is smallest, time forgets, just a little, which way it is meant to go. There may be no such thing as a particle that can never slow down, but if there were, it would always outrun its own light, and it might carry whispers backward through time. It is called a tachyon, and I should tell you plainly, right at the start, that we have never found one, and most physicists believe they do not exist. But the idea of them is so strange and so revealing about why time runs the way it does, that it is worth wandering through gently, like a possibility we hold up to the light and then set softly back down. Everything we know about ordinary matter tells us that the speed of light is a barrier that cannot be crossed. As you push any normal object faster and faster, it grows harder and harder to speed up, requiring more and more energy until reaching the speed of light would demand an infinite push, an impossible amount. And so nothing made of ordinary matter can ever quite get there. Light speed is a wall, and we are all, every particle of us, forever on the slow side of it, able to approach but never to arrive. Now here's the curious thought that gives us the tachyon. What if there were a kind of particle that lived on the other side of that wall? Not something that crosses over from the slow side that is forbidden, but something that was simply born fast, that has always traveled faster than light and always will. For such a particle, the speed of light would still be a barrier, an impassable wall, but a wall it approached from above rather than below. It could never slow down to light speed, just as we can never speed up to it. The faster things would be trapped on their side of the wall, exactly as we are trapped on ours, the two kinds of matter forever divided by the same uncrossable line. A tachyon in this picture could never rest, never slow, never stop, always rushing, always a step ahead of the light it gives off. And here is where it touches our question. According to the deep link between speed and time that runs through all modern physics, anything traveling faster than light would also, in a sense, be able to travel backward through it. If tachyons existed, And if they could be made to interact with ordinary matter, to carry a signal, to deliver a nudge, then that signal could in principle arrive before it was sent. An effect could come before its cause. You could, in theory, send a message into your own past. And this is precisely the trouble. It would unravel the order of cause and effect that the entire universe, as far as we can tell, depends upon, which is one of the strongest reasons most physicists doubt that tachyons are real. We have searched for them and never seen a trace. The mathematics that would describe them is riddled with difficulties. They would seem to require a kind of mass that is, in a strict sense, not an ordinary number at all, which is deeply troubling. And when something that looks like a tachyon appears in the equations of modern physics, it is almost always read not as a genuine faster-than-light particle, but as a warning sign, a flag that the theory is describing something unstable, something on the verge of collapsing into a more settled state. The tachyon, in the end, tends to be nature's way of saying that something has gone wrong, rather than something that is truly out there racing through the dark. But the thought leaves a quiet trace behind it, as the best impossible things do. For in asking why tachyons probably cannot exist, we come to see more clearly what the speed of light really is. It is not merely a limit on how fast things can go. It is, it seems, the guardian of the order of time itself, the gentle keeper that ensures causes come before their effects, that the past stays settled and the future stays open, that the story of the universe unfolds in a sensible order rather than tangling into knots. The light barrier is not a wall that frustrates us. It is perhaps a wall that protects us. So let the thought drift away softly as you rest. A particle that can never slow, forever rushing through the dark, always a step ahead of its own light, almost certainly not real, almost certainly never to be found. And on this side of that bright uncrossable line, all the rest of us, the stars, the planets, the slow warm matter of your own resting body, held gently in the proper order of time, where every cause comes kindly before its effect, and tomorrow waits patiently as it should, for today to finish first. Stephen Hawking once threw a party for travelers from the future, and sent out the invitations only after it was over. It is a true story, and a wonderful one. In a room set with champagne and balloons, the great physicist sat and waited beneath a banner welcoming visitors from times yet to come. He had told no one in advance. The whole point was that the invitation, with the date, the time, and the exact location, all written down precisely, would be published only afterward, sent out into the world once the party had already happened. His reasoning was playful but sharp. If travel into the past is truly possible, then somewhere in the future, someone might read that invitation, climb into their time machine, and arrive. The guests could come years late and still be exactly on time. He sat and he waited, and no one came. Hawking made of this gentle experiment a serious point, one he had thought about deeply. He suspected that the laws of physics themselves might quietly forbid travel into the past, not as a matter of engineering difficulty, but as a matter of principle. He gave this idea a name: the chronology protection conjecture. The notion is that whenever you tried to build a real machine for visiting the past, something in the deep workings of nature would rise up to stop you. The fabric of space and time, he suspected, would defend itself. There is a real mechanism behind the worry, and it is rather beautiful in its way. Even perfectly empty space is never truly still. It hums faintly, with restless energy at the smallest scales, a constant, subtle fizz far too gentle for us to feel. Now imagine a loop in time, a path that circles back on itself. That faint hum could travel around the loop, returning to where it began, adding to itself, and then going around again, building and building like a sound caught in a feedback loop, like the rising shriek when a microphone drifts too close to its own speaker. Hawking suspected that this runaway buildup of energy would grow so violent so quickly that it would destroy the time machine in the very instant it was switched on, sealing the loop before anything could pass through it. The universe, in this view, makes itself safe for history. It keeps the past beyond our reach, not with a lock, but with a quiet and automatic catastrophe. And there is the empty party, sitting quietly alongside the equations as a kind of soft, unscientific echo of the same suspicion. If the future holds travelers who can reach the past, then where are they? Why has no one in all of recorded history ever convincingly arrived from a time yet to come? The silence is not proof, but it is something, a gentle absence that sits well with the idea that the past simply cannot be visited. I want to be honest with you softly about the standing of all this. The chronology protection conjecture is exactly that, a conjecture, a strong and well-reasoned suspicion, but not a proven law. We do not yet have the complete theory we would need to settle the matter once and for all. The deep understanding of how gravity and the quantum world fit together that the question truly demands. And the empty party, charming as it is, proves nothing. For the travelers might simply not exist, or might not care to come, or might be unable to reach that one particular room on that one particular afternoon. It is a hint, not a verdict, a wink, not a conclusion. But I find something deeply moving in the whole gentle picture. In a brilliant man sitting alone in a room of drifting balloons, testing the very edges of reality with humor and patience, waiting to see if the future would walk through his door. And in the quiet thought beneath it, that perhaps the universe holds the past closed for reasons of its own, keeping what has happened safe and finished and beyond our meddling, not out of cruelty, but as a kind of gentle order woven into the deepest laws of things. So let that image settle over you as you drift towards sleep. An empty room somewhere with the lights turned low, balloons drifting slowly against the ceiling, 2 glasses of champagne, untouched, catching the soft light, a banner welcoming guests who never arrived, and all around it the patient, ordinary flow of time, holding firm, the past sealed gently behind us, the future not yet here, and the present, this one quiet and whole, with no one knocking at the door but sleep itself. Cross the edge of a black hole, and the future stops being a time you move toward and becomes a place you fall into. It is the strangest thing our best theory of gravity tells us happens anywhere in the universe, and it is a fitting place to let our wandering rest tonight. For it is the one corner of reality where time itself, the great unstoppable current we have followed all evening, seems quietly to run out. A black hole is what remains when an enormous amount of matter collapses under its own gravity into something so dense that nothing, not even light, can escape its pull. Around it lies a boundary called the event horizon, a point of no return, an invisible edge in empty space. Cross it and you can never come back, not because of any wall or barrier, but because beyond that edge, every possible path leads inward, toward the center, and none lead out. Now, the approach to that edge is already strange in a gentle, dreamlike way. If you were to watch a friend fall slowly toward a black hole from a safe distance, you would never actually see them cross the horizon. As they drew nearer, the fierce gravity would slow their time, from your point of view, more and more, their movements growing sluggish, their falling seeming to ease, the light from them dimming and reddening, until they appeared to hang there, frozen at the very edge, slowing toward a stillness they never quite reach. To you watching, they would never finish falling. They would simply fade, held forever at the threshold, a fixed and dimming image against the dark. But to your friend, falling, nothing of the sort would happen. They would cross the edge smoothly, in a finite time, perhaps without even noticing the moment of passage. And it is on the far side of that edge that the deepest strangeness waits. Something so peculiar that words can only gesture toward it. Inside the horizon, according to the mathematics of our theory of gravity, the roles of space and time trade places. Out here, where we live, you can move freely through space in any direction, but you are carried helplessly forward through time, unable to stop or turn back. Inside a black hole, it is as though that arrangement is turned inside out. The center, the place where all the matter has collapsed, what we call the singularity, is no longer a location sitting somewhere ahead of you in space, a place you might steer around or thrust away from. It becomes instead a moment in your future, as unavoidable as tomorrow. You could no more avoid reaching the center than you can avoid reaching next week. Every direction you could possibly move, every choice you could make, leads there, because it lies not over there in space, but ahead of you in time. And what happens when you arrive? Here, honestly and softly, I must tell you that we do not know. At the singularity, the equations of our theory of gravity stop making sense. They give answers of infinity, which is physics's way of admitting that the theory has reached the very limit of what it can describe. To understand what truly happens at the heart of a black hole, where gravity becomes unimaginably strong over unimaginably small distances, we would need a deeper theory than any we yet possess, a way of joining gravity together with the physics of the very small that has eluded our finest minds for a century. So the very center remains genuinely mysterious. The roles of space and time swapping, the singularity lying inevitably in your future. That much our best tested theory tells us clearly. What lies at the bottom of that long fall is a question we cannot yet answer. And so we come to rest at the one place in all the cosmos where the future ceases to be something awaited and becomes, instead, somewhere you are quietly falling. It is a strange and solemn thought, but I do not find it frightening. Here in the dark, there is something almost peaceful in it, in the idea that even time, which carries us all relentlessly forward, which we have spent this whole night trying to bend and loop and reverse, has its own quiet edge somewhere, a place where it folds gently into space and comes at last to its end. So let that final image hold you as you drift the rest of the way into sleep. A slow and weightless falling, deep within the dark, where the future is no longer ahead of you in time, but below you in space. And time itself, the great river, runs softly out, like the last of the sand slipping through an hourglass, into a stillness we have never seen and cannot yet name. Falling gently, with nothing left to do but fall and rest. If you are somehow still awake, still here with me at the end of all these wanderings through time, then perhaps your mind is not quite ready to let go of the wondering just yet. and that is all right. There are other journeys waiting whenever you would like them. Other long, slow nights spent drifting through the deep questions of the universe, the kind that ask nothing of you but to lie still and listen. If sleep has not yet come, you are welcome to let another of them begin and to keep wandering a while longer through the dark and the stars. But there is no need. Nothing here asks anything of you. If your eyes have grown heavy, let them close. If the words have begun to blur and soften, let them. You do not have to reach the end of anything. You do not have to remember a single thing we wondered about tonight. Not the clocks that slow, not the folded tunnels through space, not the empty room where no traveler ever came. Let it all drift loose and gentle, like things half remembered from a dream. You have spent this whole night in the company of time, the strangest, the softest, the most patient thing there is. It carried you here to this quiet moment, and it will carry you gently onward into tomorrow, whether you watch it or not. So there is nothing left to do now but rest. Let your breathing slow. Let the dark settle around you like a warm and heavy blanket. And wherever you are, whatever has happened, whatever is still to come, sleep well, my friend. Sleep deeply, and sweet dreams among the stars.